Our next presenter is the chief technologist, chief programmer at Secure, a software company based in Munich and Vienna, working with different stacks of environments, always an overreaching mission: connect ideas and provide impact with technology. He enjoys sharing his knowledge as a conference speaker and lecturer for his post-diploma courses at the University of Applied Sciences Technicum in Vienna. Please welcome on stage David Leitner.
Hi, thanks.
Welcome, David, welcome. Before I allow you to take over the audience and wow them with all your information, I just have one question for you. As you know, this is the 10th year of CraftHub, and it has grown and grown and grown, and it's getting ever bigger. And just like everything, what we're seeing is the IT world is rapidly advancing. It's gaining speed and speed and speed. One quick question for you before you start your program is, what would you recommend to a young programmer or system engineer that is just starting his career? What word of advice would you give them?
Phew. That's a tough question. I think it's a very subjective one, right? It really depends, I guess, on the talent. So I would just follow my interests if I would be in that age again, I think. And beside this, I think, as you said, our industry has shifted heavily. I think, technology and infrastructure is usually not the blocking factor these days. I mean, you still need a proper foundation, I guess, but in many situations you need to more deeply than I did when I was a junior developer, understand, I think, the domain, the product, and the whole organization, right? So this question loops actually perfectly into what I will talk about a little bit today. But yeah, I hope this has answered the question. And perfect. Yeah, for me it's fantastic to be at Craft again. I've been here a couple of times already. I always enjoy this conference. I always enjoyed it as a visitor. I always enjoyed it as a speaker. I think it's just a fantastic organization, and the weather is great today, so even better. So what I usually talk here about so far was very often event-driven reactive architectures. That's usually what people tend to know me for, or distributed systems in general. And I figured out over the last couple of years that what I do is obviously not so unique in that sense, that I usually work in, I would say, more complicated, complex systems and try to figure out ways how to improve those systems, right? So this whole sociotechnical stuff around it. And that's what I would like to dive a little bit deeper into, right? Most of us are working in legacy systems these days. We will define what legacy actually means. And I would like to give you a little bit of patterns which we observed over the last couple of years in this area. And I had a couple of interesting discussions up front with a couple of people I know from the community to share a little bit the thoughts. And so this is kind of a little bit a collaborative outcome to distill a few things here. But first things first, who am I? I'm a coding architect at a company called Square, right? That's how I usually tend to call myself, because I still love coding. I still love to do architectural work. And somewhere in this intersection, like Gregor Hope always calls it, I think this elevator architecture, right? I think fits my role quite well. I'm coming from Vienna. I'm these days mainly located in Munich. So yeah, that's why you probably don't see me in Vienna that often anymore, and more often these days in Munich, if you were asking yourself that question. And as I said before, I love working with legacy, right? I think it's kind of a, I would say, risky statement to do so. Hope not everybody who is kind of, contradicting me for things has heard this now. But I love really working in these complex domains, kind of things where a lot of stuff is already there. So who of you is working in a greenfield project right now? Okay, and who is working in something which we tend to call brownfield? Yeah, so the large majority as always, right? And that's I think why this talk is good for you, because I will share some patterns on that stuff. So the question is, of course, where is all this legacy coming from? And a few years ago already, I was a former colleague of mine. We tried to plot out a little bit where this legacy is coming from, right? Which is, of course, a big question. And we figured out that it's quite interesting to think a little bit historically about, those big systems and how they kind of, got to where they are right now. And what we did on a piece of paper back then, and I tried to visualize this in this presentation a little bit better now, was to decide what is actually driving things to become legacy, right? And the most obvious first one is, of course, the product itself, right? The product which we are building with software, right, changes over time, changes heavily over time, right? There are new visions, there are kind of new USPs which we need to fulfill with our product. There are new kind of non-functional requirements, right? Our product maybe gets rolled out to multiple countries, needs to support multiple languages, all these things, right? So products seem to change quite heavily, especially if you're working in digital products, right? Where the software is really the product. And if you work with startups or scale-ups, you realize this quite heavily that they are shifting a lot their focus, right? And obviously, also technology is changing all the time, right? So it's constantly changing, right? I mean, everybody knows this. Everybody who worked in the JavaScript ecosystem a few years ago realizes the hard way. Everybody who's working in the cloud-native infrastructure ecosystem these days realizes again the hard way, right? Things are constantly changing, right? But also our organizations change all the time, right? When I started my career as a software engineer, we usually worked in a classical metrics organization, right? And we shifted to autonomous teams, kind of, this whole agile movement and stuff like this. And, organizations are in general shrinking and growing, so the size of the organization is changing. Everything actually in that organization changes from time to time. Probably not that often as technology, but it's changing, right? And last but not least, individuals are changing, right? So people who initially built the software probably has left the company, right? Who had some vision in mind, who had some ideas in mind, right? Were basically replaced or substituted by others, or just moved in a different role. And other people with other ideas came in and said, hey, probably that's a better idea to do it like this, right? Without, saying that one idea is better than the other, but, just a lot of subjective opinion that, of course, plays a pivot role in our daily doing of software engineering. And all these things change all the time, right? And the interesting part is they seem to change even faster these days. Like, 10 years ago, I have the feeling. So technology, the product, the organization, the churn of people these days is amazing if you think about it, right? I would say at some point it's even ridiculous how shortly we sometimes have people in projects to basically, deliver that stuff. And the product, for example, as I said before, is adopting, is moving, right? And of course, our software kind of, needs to follow that path, right? Domain-driven design in a nutshell, right? If the software changes a little bit, or the domain changes a little bit, the software should also adapt to this change in the domain, right? And what's of course interesting is that this is not only driven by the product, this is driven by all these different aspects as I mentioned before, right? And there was a last talk from Neil Ford, I think last year or 2 years ago already, on evolutionary architecture, where he basically said, everything changes all the time, right, in unpredictable ways. That's the only constant we have. And I think it's very true, obviously, right? And, adopting our software to kind of, follow those changes, right, to kind of, adopt itself to get there is obviously hard. It's hard to, at some point in time, figure out when do we do that change, right? Can we do the change now, right? At some point in time, you realize the software, that the change is hard in the software, right? So can bugs make the change easy and then make the easy change? But when do you do this, right? You're in pressure usually, right? Maybe we go 3 more months with our current architecture all through. We know it doesn't really fit anymore, right, with the requirements we have around. And often we see, okay, people start to do this, right? Maybe they don't have the experience. Maybe they kind of underestimate the complexity, we stop it again, and we continue with where we've been. And at some point in time, we end up with this gap where we say, okay, this is what we're doing here doesn't fit anymore the requirements, right? And then we start from scratch and say, okay, let's get away from this old crap and let's build something completely new, right? And I guess most of you know the story of Netscape, right, which is often brought up in this context of building things new, right, instead of continuously changing them. And there was this great blog post from Joel Spolsky where he also referenced this story of Netscape, where you basically had in 1996, right, the version 4 of Netscape. And the engineering team of Netscape came together and said, hey, this is so far off from where we actually should be with our software. We cannot adopt this anymore. We basically need to completely rewrite this, right? And 4 years later, they came up with Netscape version 6, right? So obviously, they would have written it twice, right? And that's usually one of the cases in rewrites that you figure out, okay, it doesn't need to be better if you write it from scratch, right? But the interesting part is that this is the usage, so the usage of Netscape on the market, right? And between 1996 and 2000, you saw something, right? You saw that people were, of course, going to other browsers because, I mean, the browser market didn't stand still, right? The Netscape team was basically just working on, getting feature parity with the new browser to the old version, right? And that's, of course, a big disaster, right? Because if they would have done it right, they would have solved us or saved us from Internet Explorer, I guess. They didn't do so, right? And that's a good example of a big bang migration, right? And again, I'm quoting here somebody who phrased this much better than I ever could, right? Like Martin Fowler, who says, the only thing you ever get of a big bang migration is a big bang, right? And I think we cannot repeat this often enough. And if you take one thing from this presentation, maybe even take this one, right? So how do we avoid this, right? How do we avoid this big bang of, closing this gap here? And the idea is, of course, very simple. To basically, in increments, in iterations, adopt your architecture, adopt your software to get there, right? Like we do in software engineering itself, we refactor stuff, right? I mean, not all of us all the time, but we tended to learn it like this, right? Of course, we need to do the same thing with software architecture. And that's actually also the only way how you can achieve it, right? So you need to constantly evolve and modernize your architecture in that sense, because all the constraints, all the environments you're working in are usually changing all the time, right? And Nick Tune, he is also at the conference, I think, right? Also said, and I think that's again very important to mention. It's not the fault of an architect, right? That the architecture you have now is not fitting in the current picture anymore, right? Because even if you make consistent, good architectural decisions, right? The environment, the context, the constraints you're working in is changing, right? So of course you need to adapt your architecture. But I guess that's anyway obvious for most of you. So how do we get this done, right? And in smaller steps, the main purpose of this talk is explain how do you get from current state to target state, right? And the first thing is, of course, we need to understand why. Why do we actually need to get to the target state? What makes this target state better for us? And as I showed with this, beautiful, colorful lines, this can be a variety of things, right? This can be a shift in business, right? This can be a shift of technology, right? This can be, the reduction of costs. This can be organizational changes. This can be shift of pace. This can basically be everything, but we need to understand what are we actually optimizing for, and we need to measure it, right? We need to find ways how we can actually measure that we achieved our goals, right? So we need to find a way how we can measure it, right? And make this even bigger, right? Very important. And again, there's great literature on this, right? Evolutionary architecture from Patrick Kerr and Neil Ford and Rebecca Pearson. They basically talk about this concept of how basically can you figure out that you're going into the right direction, the whole book. And simplified, they come up with this idea of fitness functions, right? Where you say, hey, I expect this to happen if I make this architectural shift, right? I expect to decrease my incidents from 20 a week to at least 5. I expect the onboarding time for new colleagues to be faster. I expect the resilience of the system to be higher. Can be everything, right? I expect the developer experience actually to be higher, and people are not changing the company or leaving the companies often because they just say, I don't want to work with this stuff anymore, right? The important part is just that we kind of need to understand what we're optimizing for and how can we measure it, right? And then there's this target picture, right? And I'm not a big fan of target pictures because probably I'm a little bit burned in this direction, right? I worked in organizations where we were sitting together for 3 or 6 months just to kind of get the target picture from somebody, right? And then there were all these boxes and arrows, and in the end you anyway figured out that it's not working like this, right? But the target picture is still useful for I think, 2 reasons. First of all, if you make a very coarse-grained target picture, like a North Star, right? Then it gives you an incentive or it gives you an insight if you achieve the why with this target picture, right? Are we actually achieving what we're optimizing for with this target picture, right? Sounds simple and sounds obvious, but obviously there's already a first trap in there, right? And the second one with this target picture is, of course, are we moving in the right direction? Every step we take, does it bring us closer to this target picture or North Star, right? And then, of course, as I mentioned before, measure it. But all of these things are, I would say, comparably easy to this one, right? How do we actually get there from there to there? And how do we do it incrementally and in iterations, as I said before, avoiding the big bang? So we obviously need to divide and conquer our current problem space, right? Somehow we need to find a way, how do we take this existing legacy, whatever it is, doesn't need to be a monolith like stated here, but something that obviously has some problems in terms of coupling and is hard to kind of carve out and work in parallel on it. So we of course need to find those boundaries, right? And finding boundaries is obviously intensively hard in our industry, right? There was a great talk I heard about bounded context today in the morning already. So this is really the stuff I think that matters heavily, right? And the interesting thing about finding boundaries is there is no, silver bullet to say, hey, structure your software based on customer journeys, structure it based on business capabilities, structure it based on this and this and this, right? For example, business capabilities, great stuff. I took the screenshot from Linux, I think, that's kind of an architectural tool. And, you can map your business capabilities and you can even group them and say, hey, this is actually core capabilities in our software that need to be fulfilled to kind of, fulfill the requirements against the software. And, improving based on this, the modernization is, of course, quite useful to say, hey, we have a product, we have orders, we have users, we have categories. Right? This increases for sure maintainability because it's quite easy to find, hey, I need to touch something in categories, I need to go there, right? Of course, improves the adaptability and extendability, right? But in many situations, that's maybe not even what we're optimizing for, right? Just better modernization because maybe we just got it wrong and, this whole monolith is now a little bit glued together. In many situations, I see legacy modernization more for, we want to decrease the cycle times. We have the problem that our competitors are kind of outphasing us because they build features much faster than we ever could, right? And if you then think about this, and if you then think, hey, we modelize around business capabilities, right? And decreasing the cycle time is usually done by, this whole idea of autonomous teams, right? Build teams that can independently deploy, build teams that maybe can even independently own their backlog, and things like this, right? And if you do this based on business capabilities, right? If you say, okay, I want to build software faster, that's why I, build these independent teams and all of them get a business capability, then we obviously have this fact that if you want to buy a product as a customer, you first need to go to product service, right? The product service needs to fetch a user, the user needs to fetch your order, and the order service needs to fetch categories and stuff like this, right? And this is what we tend to call the distributed monolith or the entity service anti-pattern, right? So all through it could be quite useful in I would say, a different scenario to structure around business capabilities. In this scenario, it's maybe even harmful, right? So what we obviously need to do here is to kind of, structure around customer journeys maybe, right? Come up with, a value stream map and say, hey, what is actually the journey that our users want to achieve through our system? Like, I want to do product search, I want to do a product ordering, I want to do a product delivery, right? And a great way to do this is, for example, event storming. To say, hey, we figure out the processes through our system, we cluster them, and ultimately we figured out the pivotal events that, kind of are the borders between our customer journeys. And if we do it like this, right, we could then say, okay, we really build these autonomous teams. And if I want to change something in the product ordering process, then one team can hopefully, as independently as possibly, change those things, right? And we will increase the time to market. We will decrease the cycle time in that sense. And obviously, very interesting aspect of this is to even do it the other way around, right? Converse law. organizational communication, or the communication within the organization drives the software architecture. And we could use this, right? Some of you probably also know the inverse convoy maneuver, where we say, let's not figure out first how we can, shuffle around the architecture, but let's first try to shuffle around the organization that it fulfills these needs. To say, okay, we want to have a product search team, right? Not a product search service anymore, and this product search team, is responsible to figure out what needs to be carved out, right? So that they can independently deploy, that they can independently deliver value, right? Maybe they keep some stuff in the monolith because they say, hey, I don't care. This doesn't change too often, this is not critical, we can keep it there. But I as a team are responsible that I can independently work, right? And I will not go into details about this because I'm a little bit bored on this, to be honest, because I talked for more than an hour with Nick Tune on this. So if you're really interested in the inverse convoy maneuver, try to fetch this podcast episode. And we also talked a little bit about the problems there, right? That you just say, okay, I changed the organization, and then I let the teams do their stuff. Then you usually end up in a big mess and stuff like this. But it's obviously a very interesting concept to do it like this. And in this example, I also just stated one customer journey now, one customer journey to carve out. And I did this intentionally, right? Because I often have the feeling that we overdo it, right? With this, monolith decomposition. And I have a good example for this. A few years ago, I worked for a German bank where we basically had this kind of good bad bank strategy. I think it's a term mainly driven by the bank business itself. But what banks figured out is that 80% of the customers use 20% of the products, right? And you can use this for software, obviously, right? You could say, I built this new fancy web banking solution, right? It fulfills 80%, or it can be used, or it fulfills 20% of the functionality, but these are the 20% of the functionality that is used by 80% of the users, right? And the rest we just keep in a legacy system, and whenever you kind of need this nitty-gritty features, you just get forwarded back to the old system, which still supports 80% of the features that are only used by 20% of the users, right? And just the other day, as I learned software engineering or informatics, I get called from friends from time to time to fix the printer and fix the laptops. And I'm usually not a Windows user, but Windows is obviously a very, very good example to see this in reality, right? If you want to do something, you get to this fancy new system controls. And if you really want to do something, right, you get to this Windows 95 system controls, which, kind of fulfill all the requirements which you have. But of course, very complex to migrate to this new system controls. And that's one part of it, right? But also the other part, again, as I said before, what do we really need to carve out, right? Obviously, we want to have independence. We want to have high resilience. We want to have dynamic scaling. These are good examples to carve out things, right? But if you say, hey, my current solution is not properly modularized, right? Then there's no reason in carving things out. And I also brought this already a couple of times, that I think we have this strange misunderstanding in our industry between the difference of modularization and distribution. Where we have modularization on the one hand, which could be bad or which could be good, right? And on the other hand, we have deployment units, which could be very monolithic or kind of very distributed. And in many situations, we start here at the big ball of mud, right? And in many situations, unfortunately, we think that that's how things should be, right? And we think that if we shift into distribution, right, we come to something which makes more sense, which we all know usually happens in that sense that we build a distributed monolith, which doesn't make our things make our lives a lot easier. And where we actually want to be is in probably a well-structured monolith, right? If modularization is our own problem. And from there, we maybe then want to go, to kind of a distributed self-sufficient service architecture where you have this, high resilience because you have team autonomy or you have this independent deployability, right? And even if you try to get from here to here, right, it's obviously very, very hard, right? And in many situations, you end up here, which is a problem, right? Because there's this hidden wall that avoids us, at least from my experience, to getting from bottom down to top up, right? And that's why you then need to move back, right? And this is where you see that people start to migrate all their microservices in the monorepo again, because they say, okay, it didn't work out like that. Let's bring it all together, let's modularize it correctly, and let's get over there. So if you're there at this big wall of mud, I think the better approach to first get the modularization done and then get the distribution done. And I didn't mention now, although I promised to mention it, how do we actually get there, right? So this first green arrow to get from this existing code base to this kind of new wild extracted service. And I think there was an addendum on this talk title, which is beyond Strangle Fig, right? Because obviously the answer is Strangle Fig these days, right? If you talk to somebody and say, hey, how do we kind of do this migration? Strangle Fig, right? Everybody understood Big Bang is bad, so the alternative is Strangle Fig. And Strangle Fig is a fantastic pattern, don't get me wrong, right? It's a fantastic blog post by Martin Fowler, for those who don't know it, to kind of explain what Strangle Fig does, but in the end it's kind of, this real Australian tree that climbs around another tree, kind of, in the end kills it, because, it completely covered it. That's the idea of Strangle Fig. And very generic, very simplified, it's to say, okay, we build an API or we build some kind of indirection across our existing system, and whenever, kind of in reverse proxy, for example, and whenever we get a request, we take this request and either forward it to the old system, to the new system, or to the old system, depending on where our functionality now lives. But this doesn't really answer the question, right? I mean, this, again, kind of answers how do you want to be at some point in time, but not how you do this transition, right? And this transition is, of course, more complex usually, because you need to keep data in sync, right? You need to kind of keep the systems in sync. So these systems are for sure running for quite a while in parallel. And I tried to come up with a real-world example of a project we did at Square a couple of years ago already now, for a German payment service provider. It was not Wirecard, for those who are questioning this now. But basically, it was a service, that kind of allowed you to integrate to various payment service providers via central gateway. And what they figured out over the time is that they did a very good job in fraud detection. So they did a very good job in building, this fraud logic to figure out, hey, is this actually a fraudulent transaction? Should we allow it, or should we disallow it? And they did it in such a good way that at some point in time they wanted to carve this out, because they wanted to make an own product out of this. Because they said, even if people are not using our payment solution, they maybe want to use our fraud solution. And I said, okay, let's form a new team, right? Let's take the logic out, let's build a fancy REST API on top of it, and let's sell it, right? But of course, the hard part is not the logic, right? The hard part is the data. How do you get the data from left to right? Because data is per se complex, because you have usually multiple readers and writers on this data, right? And the worst is in some situations, and especially there, we had writers and readers directly in the database, right? So they were not really decoupled from the data model. And the first approach which was tried there is to say, okay, we built this new fraud service, and at some point in time, this new fraud service is finished, right? We migrate all the readers and writers. We introduce a little bit of a downtime, right? Probably one weekend, or at least it turned out to be one weekend in the end, and then we migrate all the fraud data over, right? And then we spin up our new service, and it's not working, right? And then we say, oh, it's not working, so we need to migrate back again. This reader is not working, so let's take the data back again, and then we figure out, well, we need to, of course, shut the new system down again completely, migrate the data back again, do all this stuff. And this is, as I already mentioned a couple of times, these are the situations where I get a heart attack personally, right? I cannot work in these situations anymore. I don't know. I'm getting too old for this, to sit the whole weekend and getting worried, is this not working? And if not, do we need to migrate back everything again, right? So how can we improve this? And one pattern I usually refer to is this event inception pattern, where we in many situations, just take data out of the existing legacy system and produce events out of it, right? extremely complex in reality. Again, very simplified. Everything here is simplified, right? For those who didn't guess it yet. But for example, CDC is a great, Debezium and all the stuff around is a great way to do this, right? To get a touch on legacy systems and produce whenever something is changed, an event out of this, right? And then basically, build up the read model on the left-hand side out of those events. And a colleague of mine just recently did a great blog post on this. So if you're really interested in the details, how this is done and how they did it in various situations, depends strongly on the database system and many other factors, but just check this out. And the idea is now that we have, all these events and that we can build up the read model on the left-hand side. And if we have this read model, we can, step by step migrate readers, right? Because there's, of course, a little bit of eventual consistency and latency, but they can start to read this stuff on the new service, right? But in many situations, these read-first migrations are a little bit hard because usually, teams which need to be migrated to the new service have readers and writers. And they have zero interest to say, okay, now I migrate all the readers, and in 6 months you come again and tell me I need to migrate all the writers, right? So usually you need to migrate teams completely, so you need to migrate readers and writers in parallel. And a way to do this is, for example, to kind of close this loop, right? To send also events when there's changes on the other side. Or you don't need to do this by events, you need to do this, you could, for example, just trigger an API on the old system. And there's a great blog post also from James Lewis on the Martin Fowler page on I think some kind of similar patterns. I didn't fully had the time to go through it, but they call this, for example, the legacy mimic pattern, where you just kind of treat the old system as it is, right? And it doesn't even need to understand, there's kind of a new system working on the left-hand side of us, and basically triggering this old system to keep it up to date. However you do this, in the end you have the big advantage that you can, migrate readers and writers, and if this writer is not working, right, you say, okay, let's migrate to the old system, let's go into a pleasant weekend, right? Let's fix it on a Monday, and with a fresh head, the fix is usually better, and then let's migrate it back again, right? This is how you want to have those things done, right? This kind of way of incrementally shifting, from legacy systems to new systems by this kind of transitional architecture I just showed, right? Because in the end, most of the stuff which you built here, you wouldn't need in the future, obviously, right? You don't need the upper event loop here. You can close it. Probably you want to have the lower event loop because it's already producing nice events if you structure them correctly. And at some point in time, you just say, hey, I introduce a feature flag, and at some point in time, I just stop producing this kind of calls back to the legacy system, and I just stop producing events from the legacy system. And at some point in time, I just shut down the legacy system, hopefully, right? And I just want to give you some examples that this is not just, theoretical. We do this quite heavily. These transactional architectures, I think, are very important, right? They're kind of a step-by-step recipe how to get from one state, right? In this case, you see this whole change data capture on a mirror board, and we just started to produce these events, and at some point in time, we started to consume them. At some point in time, we started to shift, who is basically the owner of this data, right? Who is the source of truth? Because even if you do bidirectional things, you always want to be one in the driving seat, at least for a portion of this data. And ultimately, we can shut down the legacy system then, and this database in the legacy system is just, kind of the read model for legacy use cases, right? So we kind of can keep this there because maybe you have some old applications or some published or public APIs that still need to read from that data, right? And you could even do more if you follow this, again, simplified example there, but you can do canary releases, right? Probably most of us are used to canary releases, but the idea is great, right? And I still see it way too less used out there to say, okay, we deploy this new service, right? But we keep 90% of the traffic on the old system, and we just migrate 10% of the traffic to the new system. And if we see that's working, right? If Datadog or Dynatrace tells us, hey, this is really nice what you're doing there, that this service is performing quite well, then we increase this, right? And say, okay, let's take 20% of the traffic. Let's see if it's still working. At some point in time, we obviously end up at 100%, and we can again shut down the old system. Or we could also do things like dark launching. To say, well, canary releases are great, but I'm a little bit more certain, so let's keep 100% on the traffic on the old system and just, keep this new system running. Don't let it do any requests. Just see if it's running properly in our environment, right? These are things which you can do if you kind of, can go back and forth based on the way how you plan to migrate your system. Or you could also do the scientist pattern. Does anybody know the scientist pattern? Okay, nice. This was coined by a GitHub blog post, right? At some point in time, a few years ago, I think this blog post is also nearly half a decade now, but they changed the way how they merged. I don't know all the details anymore, but somehow they built their own merging mechanism, right? Don't ask me why. And after some time, they figured out it's not so great to maintain an own merging kind of logic. Just use the one from the GitHub from the Git client. And they figured this out and they said, okay, we need to change this, right? We need to replace our merging mechanism with a different merging mechanism. And we did this also a few years ago for an insurance company when we calculated underwriting and pricing, right? So for those who are in insurance from time to time maybe know these terms, but basically just give me the price what I will have to pay to insure my car. And these are good examples where you can use the scientist pattern. And the scientist pattern basically just says, okay, we have the new service, we have the old service, and we basically send requests to both services, and then we figure out how are these services performing, right? This is the info where you can see them from the GitHub change. How is the performance between those two services, right? Which merge is performing better? Are these merges actually producing the right results or the same results, right? And if they're not producing the same results, is the old implementation wrong or is the new implementation wrong, right? And that's, of course, very interesting to do because, again, this gives us a lot of certainty when moving from legacy to new systems. And, of course, this works very easily if you have kind of stateless procedures, but it also works if you kind of have a little bit more complex context-dependent stuff around, right? But again, this just works if you do it in a very iterative way. Or last but not least, you could also think of something which we tend to call dual transformation, right? Where we say basically, and that's driven by this book of dual transformation, where we say basically we have this old and this new system, right? Or this old and this new product. And we try to let them even compete for quite a while. We say, okay, we either try to improve the current situation by, refactoring, modernizing the old system, or we build a new system, right, where we say, hey, this system will be so much better that it will kind of, replace the existing system. And a few years ago, I think 3 or 4 years ago, there was a great talk from somebody who talked about Prezi, how Prezi did this a while ago, when they basically had the situation that the technology was outdated. It wasn't supported by browsers anymore. So they were in this situation of saying, hey, do we build everything from scratch with a new technology, or do we try to shift our whole legacy code base to a modern technology? And they decided to exactly do this, right? To say, okay, one part of our organization is building a new product, another part is kind of refactoring the existing stuff. And in their case, I think they went on with the newer solution. But for example, another good example is Google Inbox and Gmail, right? Which did a very similar move. Right? They introduced Google Inbox a while ago, and they figured out, okay, nicer product, but Gmail is so high of heavy in features until we get feature parity, it doesn't really work. So let's take the best features out of Google Inbox and let's migrate them back to Gmail, and let's stay with the old solution, right? And these are just a few examples which I wanted to give you, but all this is just possible because we do migrations incrementally, right? incrementally. Okay? So let's quickly sum up. I think what's very important to understand, and if you work a lot in this kind of context of brownfield applications, you probably know or observed this already, but architectural modernization is like open heart surgery on a legacy system, right? So it's very important that we keep the patient alive, right? Otherwise, we make nobody happy with our adoptions. And I try to, again, simplify, show you this way how to get there, right? First of all, clarify what you're optimizing for. Why do we actually want to get there, right? why do we want to use this new JavaScript framework? Why do we want to go to distributed systems? Why do we want to build, microservices that support autonomous teams? Right? Why do we do this? What problems does it solve for it? And basically find a way to measure this. Find a way, hey, when we are there, how can we ensure that this new system helps us to achieving what we wanted to achieve initially with it, right? Streamline this target picture and make it very transparent. Probably that's the most important thing about this target picture, to make it clear to everyone, hey, this is where we're going and this brings us those and those and those and those benefits, right? Feature teams are completely full with backlogs usually, right? They are not happy to see somebody coming around the corner and say, hey, we migrate everything to microservices now, right? If you don't explain them what will improve in their life of their daily job if you do this, right? And last but not least, incrementally move to this target picture, right? Step by step. And guess what? Just stop if it doesn't bring value anymore, right? You don't need to carve out the whole monolith, right? Maybe a lot of stuff which is living there actually is not used anymore, is rarely used, is not changing anymore, is not a bottleneck in performance, can just live for there until it dies, right? So let's be very, very target-oriented in that aspect, right? And as I said before, incrementally do this. Do this incrementally. And that's why I showed you a couple of patterns which I found useful over the decade of the last couple of years to use. So thanks a lot. I hope this was useful. This one. My slides are gone.
We can't go back to the slides right now. Okay, this we can.
Super.
Okay, David, thank you very much.
You're welcome.
Listen, you went a little bit over time. We have time for one question. When decoupling monoliths, what do you think about using data science to create the most independent groupings based on user stories or trace paths?
Yes, I think it's a great way to support finding those independence paths or decoupled things that bring business value through your system. So yeah, I would take it not as the single source of truth, but I would take it as one of the methods to basically figure out what is really worth being carved out, and then to be actually able to work independently if everything else in the system is not working.
Okay, thank you. You please use Slido to give your feedback to David. His video will be up on YouTube under CraftHub. I don't know if you've allowed them to use the slides also.
Yeah, sure. I will show
them.
them.
Slides will be there also. We're pressed for time. Thank you very much. We do have a small present for you. We give you a nice shopping bag that when you go shopping, you can say, I was at CraftHub. I think you might find a few things in it. So thank you very much for being here and teaching us a few things. Another big round of applause.